Hello, I'm Professor Chuka Ngoyi, a professor of regenerative chemical process analysis and empirical model. Today, we want to talk about the solar system. Solar system is about the radiation of the sun, um, incident on the earth to produce energy which we convert and use in our houses and some of other things in the farms, the industry, and all that. Now, this model was called from the research was carried out by looking at the interaction between the solar energy transmissivity and the latitude and longitude and the incident angle of the radiation. So the question now is, can you solve this? In this work, the model evaluates the radiation transmissivity based on the values of the latitude and the incident angles of the radiation. Now, these are the parameters that shows that represent the solar radiation transmissivity, incident angle of the solar radiation, and then the latitude angle of the solar radiation. In this work, the only empirical constant we have here is n to be equal to 0.2. The value of this n will influence the values of any of the parameters we intend to calculate. Now, let us get down to the problem solving. In this case now, we want to solve a problem that has to do with solar system as it regards solar energy transmissivity. Now the question says, calculate the latitude angle of the radiation, of the solar radiation, latitude angle as it relates to the solar radiation transmissivity, where we have the value of the incidence angle to be 16.1 degrees, and then the solar energy transmissivity is 0.88. These are the parameters we are going to work on in order to evaluate the latitude angle of the radiation. So if we need to introduce these values, if you substitute these values now to the model, which we have also represented here, we have the only unknown here is the latitude angle of radiation. And we want to solve this the same way anyone can solve simple mathematics. And so, beginning with that, we're going to multiply the indices of both sides of equation 1 by 1 divided by 0.2 in order to clear the right-hand side. Since what is the right-hand side is raised to power 0.2, in order to remove the 0.2 and then get the unknown, we multiply the indices of both sides by 1 over 0.2. And that is what we have in equation 2. Now, evaluating the left-hand side of equation 2, having in mind that 1 over 0.2 is equal to 5. We now have that 0.88 to power 5 is equal to the latitude angle of radiation over 16.1. That's equation 3. And if we go further to evaluate the left-hand side, we will find out that 0.88 raised to power 5 will give us 0.528 to be equal to the angle of latitude all over 16.1. And if we make the latitude angle of radiation the distributive formula, just like in mathematics, if we make it the distributive formula, we'll have that theta will not be equal to, that is the angle of radiation, so angle of latitude will be equal to 0.5. That's what it's going to be. And then, if we now make a summary of the whole what we have done or the answer we have gotten, we will now say that the latitude angle of the solar radiation gives is 8.5 degree. That is what it's going to give based on our calculations. So you can see that this is a simple mathematics, but we are concerned with using mathematics to solve processes and system questions that are beginning to be answered. We use mathematics to solve the problems once we have the model or the equation. And that's exactly what we have done here. So I want to thank you again for listening. The model source is the conference proceeding of the Materials Society of Nigeria, the 2021 conference that was held in Nanda Azikiwe University, Oka. That's where the model was called. In the research was submitted there. I want to thank you sincerely for being part of this. I'm still your instructor, Professor Chukamoyi. Keep watching our lectures. Keep watching each episode we present. And I want to please request that you continue to subscribe to Systems and Process Mass ELAB. I'm surprised. I know that some of our viewers will be surprised that we now have Systems and Process Mass ELAB instead of Metallomaths ELAB, where the change of the ELAB or the subject of this project is in responding to the yearning request of our YouTube family. They requested that our mathematics should be of systems and process phenomenon. We use math to solve some of the problems that are beginning to be answered, and that's why we have changed the name from Metallomaths ELAB to Systems and Process Mass ELAB. Thank you for listening, and bye.